Hey guys, my name is Felix from examsconnect.com. Welcome to our physics class. We are looking at the second part of physics 1, which is units of measurement. Units of measurement. Units of measurement. Units of measurement. Now, long time ago, the scientists required to have a common units of measurement. You can imagine where different people from different regions have their own units of measure. They require to have one common unit of measurement so that they can have each quantity being defined independently from every region. So when I talk of a kilo, a pound, then it means the same thing at every part of the world. Now, these units of measurement, we start by first defining what is measurement. Now, measurement is the activity of finding the quantity of an object or a substance. You have the measurement part. Now, the most common units of measurements are known as the SI units. The SI units, where SI stands for Standard International Units. Now, these are the globally accepted units to be used as a form of measure. And they were agreed by all the scientists so that when I talk of a kilo, it is known globally what the kilo stands for. Now, there are two types of quantities. There are two types of quantities that are used in measurement. The first group is known as the physical or fundamental, also known as the basic quantities. Physical, fundamental, also known as the basic quantities. Group 2, we have the derived quantities. The derived quantities. And what is the difference between these two? The physical quantities are the agreed. They are the 7 agreed quantities. The 7 agreed quantities globally that they can measure each and every quantity in physics. These are the physical quantities. They are the 7 SI quantities that we are going to look at in a few minutes. What about the derived quantities? The derived quantities are gotten from the physical quantities. So you may take one physical quantity and divide it by another physical quantity. We are going to give examples. For example, when you talk of a derived quantity, I can take the case of velocity, also known as speed. Now, speed is gotten from two quantities. This is distance divided by time, whereas distance and time are physical quantities. So these are a good example of the derived quantities. We also have others like volume. Volume is also another derived quantity. It is gotten from the cube of distance. This is distance cubed. It gives us the volume of a space. These are just examples of the derived quantities. The derived quantities are gotten from physical, fundamental, or basic quantities. Now, when you narrow down to the physical quantities, we have 7 physical quantities. The first one, I'm going to have the quantity here. We have the unit that is used to measure the quantity and the symbol. So we have one column for the quantity, the unit, and the symbol. So the first one is length. The first quantity is length. Length is the measure between 2 points. And this one is measured using meter. And the symbol is M. Now, depending on the region you come from, the meter can be spelled that way, or you can have it as meter, depending on the region that you come from. Next, we have time. Time is the measure between two events. It is the measure between two events, and it is measured in seconds, and the SI unit is small s. Then we have another quantity, which is temperature. Temperature is the degree of hotness or coldness of a body, and it is measured in Kelvin, and the unit is capital K. Next we have mass. Mass is the amount of matter that is contained in a substance, and it is measured in kilogram, and the symbol is kg. Next we have another quantity. Remember that there should be 7 SI units. There should be 7 SI units. Then we have luminous intensity. Luminous intensity. Luminous coming from the word light, and intensity is the measure of how bodies behave in the exposure of light. Then we have this as being measured in candela, and the symbol is CD. Finally, we have the last unit, so that we can have them as 7. Amount of substance. Amount of substance. We are not looking at the molar level of a body. We narrow down to how can you quantify the amount of substance. Now this is more of chemistry, but we have the unit here as mole, and the symbol is MOL. So these are the 7 agreed. 1, 2, 3, 4, 5, 6. The 7th one is electric current. So amount of substance is measured in mole, and the symbol is MOL. Finally, we have the 7th one, which is electric current, which is measured in ampere, and the symbol is a capital A. That is for electric current, is measured in ampere, and the symbol is a capital A. These are the agreed SI units for every quantity out there in physics. However, we can add prefixes. Some prefixes are added in these quantities. For example, common prefixes include giga. Giga, which means 10 to the power of 9, and the symbol is a capital G. Then we have mega, which is 10 to the power of 6. 10 to the power of 6. And the symbol is a capital M. Therefore, I may come up with an example. Convert 100 megabytes into gigabytes. Convert 100 megabytes into gigabytes. This is how we convert it. Remember that 1 gigabyte is 10 to the power 9 of the bytes. Giga means 10 to the power 9, and 1 megabyte means 10 to the power 6. Therefore, we just need to divide. We need to convert 100 MBs to become gigabytes. Therefore, we divide by 1,000. You look at the difference between 10 to the power 9 and 10 to the power 6 is 1,000. So we divide by 1,000. That gives us 0.1 gigabytes. So when you're talking of storage in your computer, you talk of 100 MBs, you can convert that to gigabytes. We also have other prefixes. For example, we have kilo. Other prefixes include kilo. When you talk of a kilo, it means 10 to the power 3. And that is given by a symbol K. For example, convert 10 kgs into grams. 10 kilograms into grams. In the solution, we are going to have 10 kgs multiplied by 1,000, or 10 to the power 3, because we know that K means 10 to the power 3, so that we can have this as 10,000 grams. 10,000 grams. Another common prefix is deci. Deci meaning 10 to power negative 1, and it's given by a small d. We also have milli. Milli is 10 to power negative 2. Pardon? Milli is 10 to power negative 3, which is given by a small m. We also have centi. That is 10 to power negative 2, and it's given by a small c. These prefixes are fixed in front of our unit. So I can also have a deciampere. I can also have a milliampere, because ampere is the SI unit. And when I talk of a milliampere, I mean 10 to power negative 3 of an ampere. That's a very small unit. That's a very small unit. Now, when you're looking at the measurement, you also need to look at some few other things. For example, there are some factors you need to consider when you're choosing the instrument of the measure. Before you choose the instrument of the measure, you need to consider some few factors. For example, how big is the object? So when you're choosing, before you start using the units, during the measurement part, before you start using the units, you need to know some factors that you need to consider. Factors to consider when choosing the instruments of measure. The instrument. There are just two factors. Number one, we have the accuracy. Number two, we have the size of the object. And when we talk of the accuracy, we are talking of what is the smallest unit that can be measured by that instrument, because it will affect your results. So when I talk of the accuracy, I mean the smallest unit that can be measured by the instrument. And when I talk of the size, this is a property of the body that you want to measure. So I think with that, that's all about the units of measure. We have more to come. But with that, that's just a basic introduction on the units of measure and also the accuracy part as we have defined it. So thank you.